Okay, part B. So show that the Cartesian equation of C may be written in the form y equals x to the power of 2/3 minus 9, all to the power of 1/2, where x ranges between these two values, a and b, stating the values of a and b. Okay, so what we want to do is we want to get rid of t. We've got two equations here. We've got equation in x and t and an equation in y and t. We want to bring them together to form an equation in y and x. So we need to kind of be thinking about a trigonometric identity that includes sec and also includes tan. And the one that kind of jumps out at me is 1 plus tan squared t equals sec squared t. And this can be easily derived from cos squared theta plus sine squared theta equals 1. And I'll probably do a video all about how to derive trigonometric identities. For the time being, just let's accept this as a mathematical fact. So where do we go from here? Let's try and get x in terms of sec squared and y in terms of tan squared t. So let's start out with x. So we have this equation x equals 27 sec cubed t. So first things first is let's divide through by 27. X over 27 equals sec cubed t. If we take this whole thing, we cube root this whole thing, it's going to give us x in terms of sec t. We need sec squared t, so we need to square this. So that's going to give us x over 27 to the power of 1/3 all squared equals sec squared t. So I can tidy this up. 27 to the power of 1/3 is 3. So that's the cubed root of 27 is 3, and then square that equals 9. So a way of rewriting this would be x to the power of 2 over 3, that's cubed root squared, all over 3 squared, which is 9, equals sec squared t. Alright, so that's the first bit done. So let's do a similar process for y. So we have y equals 3 tan t. So y over 3 equals tan t. So y over 3 all squared equals tan squared t, which is the same as y squared over 9 equals tan squared t. And so now we can just substitute y squared over 9 for tan squared t, and x to the power of 2/3 over 9 into sec squared t. So I'm just going to scroll down to give us a little bit more space. So one plus tan squared t, which is y squared over 9, is going to equal sec squared t, which is, we found out earlier, x to the 2/3 over 9. So if we just multiply everything by 9, that's going to give us 9 plus y squared equals x to the 2/3. So let's pull that 9 across. y squared equals x to the power of 2/3 minus 9. And then we want to find y, so let's square root it. And that's the same thing as taking it to the power of 1/2. So that's x to the power of 2/3 minus 9 all to the power of 1/2. Okay. And it wants us to state the values of A and B. So we're pretty much done. That's 2 out of the 3 marks. But the 3rd mark we get for stating the values of A and B. So what are the values of A and B? Well, let's have a think about that. So the minimum value of x is going to be here when x touches the when the function touches the x-axis here. Y is equal to 0, and that's the first value. That's the lowest value of x. All other values of x are higher. So y is going to equal 0 when tan t equals 0. Tan of 0 equals 0, and t is ranging between these two values, 0, 0, and pi over 3. So we have this function, this equation, x equals 27 sec cubed t. Well, sec cubed is the same thing as 1 over cos cubed t. So when t equals 0, cos equals 1. So the lowest value for x is going to be 27. If we plug in 1 into this formula. And t ranges between 0 and pi over 3. Okay? So what is x going to be when t equals pi over 3? So cos of pi over 3 equals 1/2. So we're going to have a value of x being equal to 27 over 1/2 cubed. And this is equal to 216. So when t equals 0, cos of t equals 1. And the minimum value of x is 27. And when t equals pi over 3, cos of pi over 3 equals 1/2. And so the maximum value of x is 216. And so we can say A equals 27 and B equals 216. There we go.